Welcome to the Explainer. Today, we're going to break down something that's, well, absolutely critical for the future of AI. How do you teach an AI to know its own limits? How does it know when to say, I'm not sure?
So let's just start right there with that core question. Think about it. If we're going to rely on these things for customer service, for diagnostics, for anything important, they can't just be guessing all the time. They have to know when they're out of their depth.
Because we've all been there, right? You ask a chatbot something, and it gives you a totally wrong answer with what feels like 100% confidence. That's not just a little unhelpful, it can be a real problem. The goal isn't an AI that knows everything. It's an AI that knows what it doesn't know. So how in the world do developers pull this off? Well, here's our roadmap. We'll look at the uncertainty problem itself, then how they actually measure confidence, set some smart rules, design a playbook for when things get tricky, and finally, bring in the all-important human safety net.
All right, first things first. We have to get our heads around this idea that for an AI, being uncertain is actually a good thing. It's a feature, not a bug. It's a sign that the system is smart enough to second-guess itself. And this is the puzzle that keeps AI designers up at night. It's one thing to just pour a ton of data into a model. It's a whole other challenge to build a system that can actually think about how good its own answers are.
The answer? You have to turn that fuzzy human feeling of, I'm not so sure about this, into cold, hard numbers. You have to quantify it so the AI has a clear set of rules to follow.
So how do they do that? How do you take a concept like confidence and turn it into something a computer can actually work with?
Well, it all kicks off with this thing called a confidence score. Just think of it like a percentage, from 0 to 100. When you ask an AI a question, it's not just spitting out one answer. Behind the scenes, it's looking at all the possibilities, all the intents, and giving each one a score.
And here's a peek under the hood. A user asks about their order, and the AI is like 85% sure they want to track it. But it also sees there's a 10% chance they just want the status, and even a 5% chance they want to start a return. A basic AI just grabs the top one and runs with it. A smart AI looks at this whole picture.
Okay, so the AI has a list of scores. That's a great start, but it's not enough. A score by itself doesn't mean anything. You have to give the AI rules for what to do with those scores. And this is where developers basically become referees. They set up these predefined values called thresholds. You can think of them as lines in the sand. If the AI's confidence crosses a line, it triggers a specific action. Here's a really common way to set it up. If the confidence is super high, say over 90%, the AI just goes for it. If it's in that middle zone, it might move forward but ask, hey, did you mean you wanted to track your order just to be safe? And if the confidence is low, it just stops. It doesn't guess, it asks for help. And here's the crucial part. These numbers aren't one size fits all. If you're building a chatbot that recommends movies, who cares? The stakes are low. But if you're building an AI for a bank or a hospital, you are going to set those thresholds way, way higher to make sure it almost never makes a mistake. All right, so thresholds tell the AI when to pause. The next step is escalation logic, which is the playbook for what to do next. It's the AI's guide for navigating those moments of doubt. Now, you can start with a really simple if this, then that kind of logic, but things get really interesting with more advanced logic. It's a much smarter approach that doesn't just look at the number one answer, but at the runner-up too. So check this out. The advanced logic says, okay, even if the top score isn't a slam dunk, if the gap between it and the second place option is huge, then it's probably a safe bet. This stops the AI from getting paralyzed when one answer is clearly the front runner, even if it's not 99% certain. It's just a much more human way of making a call. But what happens when the logic runs out, when the AI is just totally stumped, and the scores are all jumbled together? Well, that's where the most important piece of the entire puzzle comes into play. A human in the loop. This is, without a doubt, a non-negotiable part of any serious AI system. It's the ultimate safety net. It guarantees that no matter what, the user's problem will get solved, even if the machine can't handle it on its own. And for this to actually work, that handoff has to be seamless. The human agent needs the full story, so the user doesn't have to repeat everything. We all hate that, right? The system needs to be upfront and say, I'm getting a person to help, and it has to set expectations about how long that might take. It's all about not wasting the user's time. So when you put this all together, the scores, the smart thresholds, the nuanced logic, and that human safety net, you move past just building a confident AI. You start building a truly competent one.
And really, that's what this all boils down to. Trust. Building trust in AI isn't about pretending it's perfect. It's about building an AI that's honest about its own limitations and has a rock-solid plan for what to do when it hits them. So this shift, this move away from chasing perfect certainty and instead embracing intelligent uncertainty, is not just making AI a little bit better, it's what's making it smarter, safer, and ultimately a whole lot more useful for every single one of us.